quick intro on the CloudFabrix. We are one of the AOps solution providers, and like all AOps platforms, it's using how you use machine learning and algorithms to accelerate the decision making, whether you are in IT ops. And one of the key things is it's not AOps is seen as a broad set of outcomes. It's not just for IT ops, for ITSM, various aspects of the IT. And today we'll be covering about the alert noise reduction, but in the subsequent sessions we'll cover different use cases and outcomes. So with that, we'll get into the actual part of the topic. And here is one framework which we really kind of liked it. And alert noise reduction is probably one of the most common use case we hear from the customers. And this is probably the first aspect of the journey. And once you start that one, and then you can go into how you accelerate the MTTR and how you accelerate the time to detection. And finally, the end goal is prevent incidents altogether. But today the session will be most focused on the alert noise reduction, and we will focus on how actually it helps, right? And in the subsequent sessions, we'll be talking about the rest of the outcomes. So when you look at the alert noise reduction, if you take traditionally the way things are done, you have a lot of monitoring tools, you have IT assets, and you have different monitoring tools for various aspects of the IT assets. And they typically look for some health rule or some kind of condition, and they raise a ticket or raise an alert, which end up being a ticket in your ITSM tool or get somebody notified through email or page notification. And that is one of the major problems today, because they're all designed to alert somebody as quickly as possible with any condition. And that tend to raise a lot of noise. And that is where the AOps will come in. And that's where our solution, the first thing you need to do is we plug the AOps solution sits in between your monitoring tools and your ITSM or some kind of command center or notification. And then these are the sequence of steps it goes through in how it reduces the alert noise. And we will walk through each of the steps in detail as we walk in the subsequent sections. As we said, right, the first and foremost thing is, instead of having the alerts go into the ITSM systems, first you need to route them to your AOps solution. And how do you do that? So if you're on the left side, you have a lot of different monitoring tools, APM tools, log monitoring tools. You need to make sure that all the alerts, whatever the source you have, first need to get into your AOps systems. So how do you get that one? So you have multiple, this is one of the key things. So because each tool may have different interfaces, some of the modern ones will support things like webhooks or Kafka based, messaging bus based. But you run into situations where some of the tools only sends emails, some you may have to get into their databases, some support APIs. So you need to make sure the AOps solution supports wide variety of methods, so that way you can get as many tools as possible into your AOps. Ideally, you should have all alerts go into the AOps. That is where you will get the real efficiency. So that is the first and fundamental thing. Make sure that your AOps solution supports all the different protocols. Then here are some of the examples, how the different things we have seen in the industry, whether it is file-based or API-based or pub subscription-based, or the Kafka or RabbitMQ. So these are some of the methods. Again, another thing is, once you get in from the various protocols, typically they normalize into single protocol, and all the transformation happens here. And we in our CloudFabrix uses Kafka, but there could be other methods. Kafka is picked because it gives you a lot of scalability and high throughput. So internally we use all those protocols will get into Kafka topic and get pushed into AML engine, so for further processing and analyzing. So once you have ingested the alerts, the next thing and next two topics are probably the next two steps are probably the most critical ones. And this is where the alert enrichment is. Basically, if you look at traditionally, one of the biggest drawback is most of the alerts coming from the monitoring tools have very little information. They might have message, some severity, and some IP or CI details, but you don't have a lot of context. And this is where you really need to enrich that alert with additional context. And the AOps solution should make sure most of the process is automated, because if you have to rely on some rules based or tagging based or source based enrichment, it's not very scalable, because typically when customers or enterprises deploy AIOps, there's a lot of complexity already existing in the IT ops, and you don't want it to add another layer. So very important that all these things are automated. First and foremost is the what we call as stack or service layer. You need to make sure your alert is enriched with what service it belongs to or what kind of stack it belongs to. The stack is a loosely term, which is basically, it could be a service or it could be a group of assets that a support group could be handling it. You need to make sure that whatever the context that as per your operational process, it gets enriched automatically. And this is where the tool should have inbuilt asset intelligence to automatically learn these dependencies and feed that information into alert automatically. The second thing is you need to make sure that you can enrich that with a lot of the other sources you have. And this is also one of the key things is you should be able to automatically discover, for example, if I get a device name or IP address from the alert, can I look up in my CMDB or some other log files to understand other details for that IP, whether it is it belongs to certain machine, or what name, who is the owner of that machine, or where it's located, whether it is coming from CMDB or other sources. You should automatically learn these things. Dependency between the data is very, very important. So again, all these things, whether you read it from your enrich with your stack, or enrich with the information from your CMDB or other alerts or log files, it has to be automated. Finally, if you don't have some of them and you still need to do some manual thing, the solution should be able to manually add that things. Ideally you should avoid these things, because especially when you are dealing with like 10-15 sources and each source is giving different type of alert types, it's definitely will become unmanageable. So you need to make sure this whole alert enrichment process is automated as much possible. We'll show in the demo how these things happens. And the next thing is, once this is like just a quick example of raw alert, and then once it goes through the process of the AIOps solution, it gets enriched with all these details. So in our implementation, we have seen close to 20, 25 or even 30 attributes that are valuable attributes. Typically you can sometimes find 50 or 100, but you need to make sure that you enrich with information that is valuable. It doesn't, if it doesn't change anything, it's not of value. But if it keeps changing, you need to make sure that variance is also factored in when you are doing the enrichment. So once you enrich it, and that is where once you have a lot more information, you can do much better correlations. So the thing is, there are two different approaches you can do. So one is, traditionally what you have to do is you should understand the symptoms automatically. So ideally your AIOps solution, what it has to do is it has to take a lot of historical alerts from all the different sources and understand the symptoms automatically and use that symptom as a way to correlate this thing. Otherwise, you have to write bunch of rules, because the correlation exists from a long time and people have done with rules. And if you have to rely on that, it's not very scalable. So you need to make sure your AIOps solution can automatically learn these symptoms by getting it trained with historical data. Once you have these symptoms, then you need to set the targets, how I wanted to correlate. And here are a couple of variables typically we see. One is the time based. I wanted to say next 5 minutes, all the symptoms has to be grouped, and that is very broad, right? Apart from the time, you need to add other attributes, and this is where the stack based or asset based, a lot of AIOps solutions do asset based, but having a stack based and symptom based is probably the one of the most highly efficient way of correlation from our experience. So you need to make sure that you have that capability in your AIOps solutions. Once you have the symptoms, and then all the services or the stacks, depending upon how your organization is structured. So once you have those stacks, and this combination of these two can pretty much address a lot of your scenarios. Symptoms and stack and the time is all you need. Ideally you should have as few policies as possible, because then it becomes manageable. So with these combinations, you can pretty much cover all the scenarios as per our experience. So this is like an AI engine, continuously test, deploy, and train. You typically, in our experience, initially at 3 to 4 months, you have to continuously do these experiments until you have all the symptoms learned automatically, and then you add the stacks and time and attributes. So this should be fairly automated. As soon as you have symptoms generated by the ML algorithm, and then the stacks getting discovered by this asset intelligence, a combination of these things, and only thing you really need to fine tune is your time window, whether I should use 5 minutes or 10 minutes or 15 minutes. And based on the type of symptoms, you may have to do that fine tuning. But apart from that, fairly, this should be all automated process. Otherwise, it can get very difficult to manage it. By default, it should also support user-defined policies. Sometimes, there are special rules that, or domain knowledge that people wanted to have it. So you need to make sure that, user also can define that policies along with your automated correlation policies that are generated with the symptom and stack based. And the other thing is very common is the suppression. It typically, this is very important because a lot of times you have maintenance windows on various assets or a data center level. You need to make sure that you don't bother your support engineers with these things. So you have alert suppression, especially if you have a change management system. Ideally, it should take that from your change management system, and suppression policies should be generated automatically. Otherwise, you should have the ability for the user to define that one. So very important, is a simple thing, but very useful in your making sure you reduce your noise with this thing. Finally, now we have looked at, right, we have ingested the alerts, and then we have enriched the alerts. And now using that enriched alerts, we are able to correlate with the stack information and other symptoms, and also use the suppression policies. Now we are left with like a few actionable group alerts, what we call as a grouped alerts, right? You typically, when you do correlation, you group certain alerts that have similar symptoms and similar same root cause as one group alert. And then you have to convert that into actionable incident. Incident is where you would typically log that ticket into your ITSM tools, so somebody can take a look at it and take actions. So that is what we basically call as an actionable incident, which is basically nothing but a ticket into your ITSM systems. And that's where that's how you reduce your noise. You basically take your raw alerts and use the correlation policies and the suppression policies to reduce that into few actionable incidents. So you can pretty much get like close to 80 to 90% alert noise reduction once you have a fairly fine-tuned system. And here is one example before we get into the demo. This is very important concept. This is where the whole stack concept we talked about is useful, right? Stack could be what in our parlance, a stack is a loosely term. You can group your assets in however you want, and that stack definition can be used for correlation. So here are two scenarios which we typically come across. One is a service level stack, where basically, if I wanted to make sure that all alerts that are happening within a certain time window and have the same root cause has to be grouped, they define a vertical stack, or it's basically it gets discovered automatically and say that this is the stack that we wanted. So anytime there is a alert, like the storage full, and then typically you see a DB getting slow, and then this will impact a service. All these things will happen within 5 to 10 minutes or 15 minutes, depending upon the scenario. You wanted to catch them all into one instance. So this is one scenario. But sometimes, people wanted to say, okay, I'm interested in correlating things across my horizontal layer, or all the firewalls to be there's a support group for all firewalls or storage disks or database servers. So that is also possible. So then you can define, all the discovered firewalls or discovered database servers as one horizontal stack. And you can have a correlation policy saying that, group all alerts belonging to this particular stack as one instance within a certain time window. So very important concepts, and you need to make sure that your AIOps solution has this kind of flexibility. So with that, we will just quickly go into the demo, and we will quickly run these concepts and how it is done, and then we'll get back into question and answers. So if you look at this one, here is very high level window. And as I explained, right, one of the key things is your tool should have automatic way of discovering all the enrichment flows. So if you feed in the historical data, it'll and CMDB data, whatever the different sources you have, it will automatically learn all the enrichment flows. So once you have these flows, it's a programmatic way of automatically doing this one. So once you have that alert enrichment, automatically discovering all the enrichment flows. So here is what your high level, what you see. Like, you have total alerts of 1608. So 1275 are correlated, and then there are suppressed and these 1600 are reduced to 81 instance. So here you are achieving 94.96% reduction. And here are a bunch of incidents. We have like internal incident creation, but ideally it will also go into your ITSM systems. You can see each incident, how many alerts are getting correlated. You can go and see what alerts are getting correlated here. So this is very important for you to make sure that, during the training period, you need to make sure all the related alerts are getting correlated properly. And we also have ways to check that one by different policies. You can also see which policies are getting working better. Here are quick analytics for you to see, where it is coming from, the various different sources, alert watches, and how the different policies, the rate and all this. So very useful to see which policies are performing well, and this will help you fine tune the systems. And we will quickly get into how this all happens. Here what we have seen is the final outcome, but I'll quickly go into the behind the scenes, how actually it happens. So here are the stacks which we talked about. These are all automatically discovered. You can create custom these things, or whatever the stacks you wanted to have, you can define these things. And once you have these stacks done, the first thing is you integrate these things into your AOps solution. So what we talked about, different webhook and CSV or Mecha notifications. So with using the various methods, first you do the integrations. And then you do the alert mapping. Alert mapping is, a lot of times you may have to do severity, like, in certain sources you will have severity as 1, or sometimes severity as 5. You have to normalize all that. And that is the first 2 steps. And then, as we said, right, first we have to do ML experiment. So where you can say that, I take all the different alerts from the historical, and you run the ML experiment to identify the symptoms. So once these symptoms are done, you activate that experiment. Once you are satisfied, like, these are the right symptoms, and then you can just activate that experiment. Once you have that experiments or the experiment activated, so you can create a correlation policies using the various parameters which we talked about, using, let's say, as a combination of stack or the symptoms. So these things you can just create it and activate this one. So once this correlation policies are activated, as well as the suppression policies is defined, and this is where you will get the final outcome. So it's fairly straightforward process. You just start using the standard out of the box integration methods. You say that, start ingesting the alerts, and you can take the historical data and use the ML experiments to find the policies. And once the policies are done, the symptoms are learned, you create a correlation policies using the symptoms and the stacks. And once that is done, pretty much the system will start automatically correlating the incoming alerts and creating an incident in your ITSM systems. And one of the things, I just forgot to mention. So as we learn the symptoms, so like once the symptoms are learned through the ML experiments and these are activated, every incoming alert has to be classified. Classification is also a very important part of the AOps solution, because only when the incoming alert is classified to one of the symptoms, your correlation policies can be able to pick it up and then group them in a very effective way.